All yours.
All
Okay,
right.
so
All right, thank you, everybody. Introduction to Engineering course. I'm going to give a presentation on software engineering. So, is it just the center one, Jim? Next one. All right. How about that one? Which clicker, Jim? Are we in presentation mode or are we still in?
we're in presentation.
Down there?
I guess so. Maybe the battery went dead.
Yeah. All right. All right. So about me. My name is Mr. Trotta. I was an SFC parent for 18 years, and now I'm a pseudo SFC parent. As one of my sons is actually working here on the IT department. If you know Paul Trotta, that's my son. And I've been a software engineer for 36 years. So I got my bachelor's and master's both from UC San Diego. So I'm locally trained, and different types of projects I've worked on in software programming. I've worked on anti-radiation missiles for defense. I've worked on a computer-optimized suspension, so for tracking the ride on a vehicle. I've worked on a lot of communication software, CDPD, PHS, or GSM phones. All these have to do with sending data packets back and forth to each other. I've worked on cable modems. I've worked quite a bit in Bluetooth Classic and low energy. I've worked on BlackBerry phones, and I've worked for Amazon Web Services, and currently I'm working for Amazon Fresh here in San Diego, and that's where I am today. So these are the different kinds of projects I've worked on. They're very different, as you can see, which is one thing I think I really enjoy about software engineering is you can go into a whole bunch of different areas and still apply the skill set and get into things that you might be interested in doing. So just to kind of give you a background on some of these things. So like an anti-radiation missile, that is a device that would protect jet planes, fighter planes from ground missiles that would use radar to try and track them. And this missile would actually recognize that radar and be able to remove that threat before one of our planes would be shot down out of the sky. So that was very important for our defense. The computer optimized suspension technology, that was really cool. We were taking the input measurements of the tires on a vehicle, and as we measured that, I would loop that back and apply the right suspension control so that when you're driving out and you're on a bumpy road, you have a good firm ride, but then if you're out on a freeway or something, you have a nice smooth ride. So it's kind of it was neat because if you go with a regular shock absorber system, you have a sporty car, which handles really well, but then it's kind of rough. Or you have a luxury car, which is really smooth, but is soft and doesn't handle well. And this would allow you to combine both aspects of it so your car could handle well on curves, but then also have a nice smooth ride. So those are things we can do in software. Yeah. So those are things I think everyone's pretty well aware of what Bluetooth is nowadays and what they do, but I was working in it for probably 5 to 10 years before people even knew what Bluetooth was. So it takes that long to produce something that now everyone sees and has in their phones and uses all the time. So that's another aspect that can be interesting. All right, so this slide is software. Kind of a little bit. So just to kind of show that software is everywhere. So if you're interested in a career in software or going into that field and have other interests, there's almost always going to be something where you can apply software with another aspect. You could be interested in music, so you could be writing software and processing music and making music better. You can be, interested in gaming. You could be interested in technology. There's all different areas. It's in aviation. It's in defense. It's in your toaster and your refrigerators at home now all have software in them so that they can perform better. And even now we're finding some of our cars now are having troubles because they can't get the chips to run the software, so we're not able to get some of the vehicles going. So it's very interesting to see how it can impact the whole world. Unfortunately, it's been helpful too because because of the software and the networks that you learn about in the courses here. We're able to do some of the things we were able to do through COVID with the Zoom calls and communication aspects of things. So. All right, so there's a bunch of different types of software as well. So this is a non-exhaustive list of the different types of software that you can have. We have embedded software. Embedded software is the software that runs on the computer chips. So it actually has a very specific role, and it's actually written for a very specific piece of hardware or what have you. You can have so things like a Bluetooth software stack is an embedded process. It takes care of all the Bluetooth knowledge, things like that. You've got cloud software. That's all all your cloud, any access that you want to store out on the cloud, software services, things like that. Applications. So those are the things you load onto your phones and onto your desktops to run, just your all your different apps that you might have on your phone, your WhatsApp, your I don't know what's the popular applications of the day. Your Netflix apps, your anything those are the things that you load on your phone. Those are different types of software you can look at. Databases, that handles data. My current work, it has a lot to do with databases because it has to do with storing data, analyzing data, and trying to figure out the best ways to make the products available for the customers and how the customers are using the products. Big data, also similar thing where you want to process. When you do an internet search today, you can get so much information. So now there's a lot more algorithms you can run on front of that can help pare down someone's search engine so that you get the answers that you want to get without having to sort through all the junk that you don't want to see. So there's a lot more activity there. Connectivity, that's just keeping devices connected to each other through wireless different areas. Communication protocols are the ways, that's the rules that software has to follow to make sure devices can talk to each other. You can work in defense. That's where I talked about the anti-radiation missile or anything there where you help protect our country. Software tools is another thing. So when you write a program, it has to run on something. Something has to interpret it. Like if you're writing if you write something in a program language, you have to have tools that can interpret that language, read it, and understand what you're trying to do. It's like a compiler or different other tools to help someone run their software better. Client server, those are services that you may have. Netflix has the Netflix is your server. You have the client that says, hey, I want to watch this movie, or I want to watch this show. So those are different areas of different kinds of software. And then you have graphics. So anything in games, where you want something to look cool, the graphics software is pretty intensive. They even, they'll make special processors to make that easier, but there's a lot of software development. DevOps is another area where it's the whole process of when you're trying to get a software product out that you can sell, it's overseeing how do you develop it, how do you test it, and then how do you ship it out to someone else, because that can be very important, especially if you want to worry about, does someone have the rights to have this software? So you have to have security issues of, can you download it? Do you have the software key? Are you allowed to use it? Things like that. There's testing. So you can go into software testing and make an entire career just testing what other people write and try and break it, which can be fun. Platform security, operating system. I mean, there's a lot. So operating systems. So that'd be like actually working on iOS and designing and making that work better. Working on Microsoft. Working on a Linux environment and making that work. And some of them are open source, so you can actually go in and do that as you feel free. So those are a bunch of different types of software. Does anybody have any questions on any of these? Has anybody done any kind of software yet? Not yet. All right. That's why it's introduction, right? All right. So then there's engineering as humor attempt. So there are 10 types of people in the world, those who understand binary and those who don't. So does anybody understand this one? All right, who can explain this one? Go ahead.
Because 10 is 2 in binary, or 1, 0 is 2 in binary.
Right, so in binary, you can only have 2 digits, 1 and 0. So to represent the number 2, you have to go into the second digit, which is 2 to the first. So that equals 2. All right. Okay.
We'll all be experts if you take comp sci next year. No binary inside and out.
It's actually, I find it really
You'll
fun.
be telling that binary joke.
Yep, exactly. You might have the shirt. That should be a prize at the end. If they get there. All right. So some of the important things and principles are the principles of importance of engineering principles for software. So I want to build in the fact that it's an introduction to engineering, and there's a lot of things that go into it other than just programming and working in software language. And you see a lot of different types of processes that go into play to help develop software. But in essence, you end up getting you have to think about the whole project, the whole system as a whole. You have to figure out what does it need to do. Like at Amazon, a lot of the processes, we say you work backwards. You figure out what does the customer want, and then you try and figure out how to get there. A lot of times when you think about a problem, you're thinking about what do I want to do, and you're pushing forward. So you're not thinking about all the things that are important. So you may add things in that you don't need. You may start doing things you don't need. So you want to do, and it's an iterative thing where you look at a requirement. You go and say, okay, let's design something to figure out how is that going to work. Then you may go, okay, then how am I going to implement it? Then you actually code it up and do it, but then you got to test it, make sure it's working right, and then you also have to maintain it. You have to keep it running and keep it working. And then it also can be very iterative. You may start doing something, you get something working, then you realize, oh, if I do this differently, it can be better. So then you go back into your requirements and say, okay, does it meet the requirements? Oh, yes. And then you look at design. How that means I may need to redesign it and re-implement it and keep it working. But what you're able to do is able to make things software better, make sure that it's always working, make sure it's always available. And I think the real key is that this is something that no matter what kind of software engineering you go into will always apply. So that's why when you start learning introduction engineering principles, all of these things are very valuable when you go into this field. It can be very easy to just want to jump in and just start programming, get excited about it, but you'll end up needing this and making sure this is well established in your career if you go into this path, so that you can be effective. You can go from different areas, different kinds of software, and continue working. And in my background, I've been able to work very close to the hardware. Now I'm much further away, and because of these principles, I'm able to go from different jobs to work on different things. And that's pretty exciting. All right. And then again, because introduction to engineering, kind of another slide that talks about different ways of how things can get misinterpreted. So communication is very important in engineering. And so you want to make sure everyone is on the same page. This also stems from you work backwards. If you work backwards from what does the customer want, it'll be a lot easier and you'll get what they want. But if you just start and you say, okay, some client describes something and it looks kind of more elaborate than they're saying, and then a project manager, this is how they understood it. So it was misinterpreted, and then how a structural engineer designed it to make sure it might be safe. And then you get these wild different combinations of things. How the reports describe it. Documentation is empty, so you don't know what went into it. Just different aspects. What the client has billed, it was very expensive, and it shouldn't have been. How it was actually built in the end, and then this is just what the client wanted. So you want to make sure that you go through all those aspects of communication. And by going through all those cycles of software, you're helping avoid a lot of these costs. And it may seem like it's costly at first because you're putting a lot of effort up front without putting anything out. But in the end, it ends up saving you a lot more money, and then you actually get the customer what they want. So that's one aspect of it. Okay. Oh, I guess I did. I kind of went through it a little quick. It seems like. So I guess any questions? Any? Yeah.
So like you said you work for like Amazon Fresh.
Yep.
When is that going to be like available for everyone?
As far as
Like delivery of groceries and stuff.
that, I don't know the answer to. I mean, there depends on different areas of Amazon Fresh do different things. Like they have some in Seattle now, some supermarkets where you don't even have checkouts. So that's one part of Amazon Fresh is you go to a supermarket, you put things in your basket, and you just walk out, and they bill you. So you don't have to wait in line. It's very efficient. So that's one part of Amazon Fresh. Other parts are how quickly can you get fresh food to your door, right? So So I'm not sure if that's the part you're talking about. If you order food online, can I get it delivered today type of a thing? I think they have some of that today, so I'm not sure. I don't use it a lot, so that's another interesting. Sometimes you don't use things that you actually work on. So, yeah, go ahead.
Your degree is in software engineering, right?
Yes.
Yeah.
What was your favorite project that you think we probably like use the most today?
That's a good question. I would say probably the thing I worked on the most that most people know and use the most is probably Bluetooth. The product that was probably my favorite one to work on was the computer controlled shock absorbers. So that one, we actually had I was working in a vehicle. The company that built it, I was contracted to that company, and they were building a Suburban and put this system on it. And one of the owners was an off-road racing champion. He won the Baja 1000, so he knew how to drive off-road really well. So we'd take the Suburban out to a racetrack, like a off-road racetrack, and he'd race it through, and we while we're racing, I'm in the back seat modifying and changing to say, oh, wait a minute, that ride was a little too slushy, we need to get a little more control, and so I could change the parameters so we could test and tune the shock absorbers for that car. And so that was really cool. So we even got to go out to General Motors proving grounds in Mesa, Arizona, and do that similar kind of testing with their devices to show it off. So it was a very exciting, fun one. So I'd spend a day driving out in the roads out in Julian, just so we could drive different kinds of roads and test it. And it was really nice because you got out and about, but you were doing software as you go. So it was a very fun job. Yes.
You went to UCSD, you said, right?
Yes, I did. Yeah, UCSD is a good software engineering school. There's actually quite a few across the country. Purdue, yeah, it's okay. No, Purdue's a great school. If you don't know, Mr. Riley went to Purdue.
UCSD or B?
San Diego, UCSD, yeah. Yes.
What were a few of like the major companies that you worked for?
So Qualcomm, Amazon. Amazon's the biggest company for sure. And Qualcomm is big. So it is interesting going from Qualcomm, which was pretty big in San Diego, and then going to Amazon, which is like makes Qualcomm look tiny. It's very interesting. So but you know, even big companies, the little companies are all very exciting. The little companies are really exciting because you can have a much bigger impact. So the smaller companies, when I was working Bluetooth, that was about 100, 150 people. And that was really exciting because you're working right with the hardware engineers, you're working with everyone that's involved, and you're having an immediate impact on everything. So that was a great area of work. Defense work is very rewarding because you're protecting your own army, your own your own country. So that was an interesting aspect there. It's all very interesting. But yeah, definitely for sure, Amazon's the most well-known of the companies. ARM is another company that has a big presence in engineering, but not necessarily in the public. So ARM makes the design for a lot of chips that go into mobile devices because their software their product is really good at battery power and low energy and making sure that things last longer. So basically an ARM processor is in just about every phone you have, just about everything else because of their design has been optimal. But even there, I was working Bluetooth for that team. So that was different. Yep.
I just have one more. How many people do you normally work with when you're on a project?
Again, that can be different from project to project to project. So currently, Amazon has what they call a 2-pizza team. So a 2-pizza team is the size of your team is just the size so that they can be fed by 2 pizzas. So 6 to 8 people is a lot of what that's kind of based on the research they've done and everything. That's the most effective way they can do things. Now, what that means is then you're working on a smaller piece that has to integrate with other people working on their 2 pizza teams and working all that together. So you need a lot of coordination. This is where a lot of the design comes into play. You need to make sure that the systems is going to play together. So if I'm working on my part and Mr. Riley's working on his part over here, if we're not in communication and they don't work together, it's no good. Now, each team is very small and efficient because they can work really fast and turn things around. But without that communication, without that understanding, the whole product won't work. So you have to make sure everything works together well.
In comparison, you talked about 6 to 8 on a particular team there.
Yep.
Amazon Fresh as a whole, how big is that?
That would be good. I'd have to look that one up. It's thousands. It's big.
Put in perspective what it takes to do something like that.
Yeah, and just like Amazon Web Services, I know. So just to give you an idea of that one. So Amazon Web Services, I was on the Internet of Things part of that team. When I started there, which was only in 2019, we had about 350 people under Amazon Web Services Internet of Things. When I left Internet of Things to go to the Amazon Fresh side, we had over 600 people, and that was only 2 years later. So that team grew immensely because that's a growing part of the business. So the team sizes can be quite large at times. And so it'd be more like, Internet of Things. There's some cooperation. Sometimes you're just building a piece that someone else uses. And then again, similar things, AWS, we're using some of the Amazon Web Services tools to even do our job. So we're even customers of our own product. That's what they call it, eating your own dog food, if you've ever heard that term. You want to make sure it's good for yourself as well as the customer. So you're testing it by using it yourself within the company. Yep.
Do you have any advice for someone who would want to go into software engineering?
Yeah, I mean, I would take the software engineering course here with Mr. Riley, because that's a good, it'll get you a good sample of how much you enjoy it. I think that's one of the biggest things is if you think you're going to really enjoy that work. And go ahead and get, there's things you can download and play with. If you start getting more into it, you can buy a Raspberry Pi and start playing with some different things that you want to try. Again, and also if you have kind of what I mentioned before, if you have other interests that really you have a passion for, and there's a software application for that, maybe start experimenting with that. Look into, hey, what can I do if I'm interested in sports? And then you see all these, these StatCast things and these data analytics of how fast was the pitch going, and you may want to get into something like that. Or if you're into music, you may want to figure out, hey, how can I write something that would help impact music? You're into games, you understand, you say, oh, wow, that's really neat. I wonder how that works. You can investigate it. But it's really good to, I think, just get a good understanding of how a language works. I think, again, as I said, I think Mr. Riley's software engineering course is a great start, because that will introduce you to a lot of things to find out what path you might want to go to. And then another piece of advice, if you go into software engineering and you're going to college, internships are extremely valuable, and not everybody always thinks about that. A lot of companies are looking for interns for the summer, and you can get paid very well for interns. I mean, I don't know. In a software intern job, you can get quite a bit. I don't know what it is today per hour. I know at some points it's on the order of $35 or more per hour just working over the summer. And then they also pay for your housing and things like that. So there's a lot of really neat opportunities, and you can find out that way. You do an internship for a company like Amazon or a company like Qualcomm or different companies. You find out, oh, that this is an interesting area. I want to go that path. So that's how you do that. Or you may say, let me try this kind of work to find out which one I like better. Do I like embedded software? Do I like cloud software? What kind of different kinds of work do I like? Go ahead.
What was when you were first getting into the area, what was your first thing that really, did you see a project that you were like, I really want to try that, or what got you into the area?
I actually, in my high school, we actually had a computer programming course, and I took that, and that was the thing that really got me interested into it because I really, understood and got how the whole logic worked, and breaking down a program. This is the first time I learned about. We had a program where we had to count down certain things, or we had to divide down something, and learning about the difference between real math and integer math, and that I had a loop that was dividing a number, and I was end up dividing the number by 3, and I was waiting for it to get down to 0, and then subtracting. I was waiting for it to get down to 0, but when you divide by a 3 in numbers, you don't get the computer math doesn't get you to exactly 0. You had to have a counter to make sure it worked. So I failed that. All right, my program failed one test case. And that, again, stems back to, hey, what are the test cases you need to understand? All the things I tried worked because I was using like even numbers and things passed correctly. But if I put in an odd number, it probably would have failed on me. But I learned, that's how I just first got into it. That was actually in a program called BASIC. And then, so that's kind of how I started getting into it. And then as I started taking it in college, I really enjoyed solving the problems. Problem solving is a great way to, if you're interested, if you like analyzing things and problem solving, that's another good way to know you might be interested in it. Yep.
How long did it take to develop Bluetooth?
Bluetooth itself, as I said, so I worked for the company that had the first qualified radio for Bluetooth, and that took, just to get the radio part working, and that had very little to do with the software, probably took about 5 years from start to finish to even get that functioning. And then working on the Bluetooth is an interesting background because it's a open spec, so everyone knows how it works. There's no secrets because I want the Bluetooth made by Mr. Riley's company and the Bluetooth made by my company to work together, right? You don't want to have to buy a phone that's manufactured by the same company as your headset. You don't want to have to buy a phone that's so now you have to mix everything up. So Bluetooth had a whole bunch of what they called unplug fests, where all the Bluetooth companies would come together and test their products together against the specifications to make sure to reduce the possibility that when it becomes a product, it doesn't work. So you want to make sure everything works properly. So overall, it took over like 10 years to actually get Bluetooth where people knew from when you started developing it, it was actually showing up in products. And then probably another 5 more years before now everyone had, I want to get a Bluetooth headset. I want to get that because I don't have to have a wire,
Yeah.
Yep.
Was there any time like you regretted your decision to become like your type of engineer, like when a project didn't work or something?
No, I never regretted going into software engineering. I still enjoy it today. It's fun, and again, because I can change types of software, it's very easy to add variety to the work. So, yeah.
Is there any other type of engineering that you thought about doing or even now want to do?
For me, no. I'd say overall, still in software itself, I really enjoy the embedded engineering part of it the most. But now as I'm getting more, and now I'm working more into the cloud side, I have a lot more respect for that aspect of the work. It's very different. It's not much. I mean, they're both very fun. I enjoy them both, but for me, the biggest one is that I like the embedded side the most, as far as the type of work I work in.
Does embedded make sense? How that differs? How embedded software? An embedded system would be something like the braking system on your car. It's all very self-contained. The computer that's creating the braking system, the software, et cetera, is all in there.
Yep.
Your laptop is a much more open system. It's got general software. You can do word processing. You can do 3D graphics. You can do spreadsheets. You can do web searching. It's much more open. You can put different types of software and it still work. An embed is usually very customized to make it as low as, you want your braking system to cost as little as possible, but still cause your car to brake. But your computer, you need it to be able to do the versatility of all those different types of software.
Yeah, and I guess maybe to even explain, why do I like embedded more? I like the challenge of kind of what Mr. Riley talked about. I like the challenge of how can I make this work with using less memory? How can I make this work with what they call a smaller footprint? Like, so the code size is small, it doesn't take a lot of time. How can I make sure it uses less battery so I make sure it can go to sleep and wake up so that it's more efficient? All those kinds of things are really intriguing to me. I like communication protocols. Communication software usually goes into embedded devices, and that's another aspect I like because it's like codes. You're breaking down information into a packet and then have to piece it all back together. So there's a lot of different things of how do I get things to work and how do I make sure that they can fit. And the more it's really interesting because you go from, okay, I'm allowed to only have maybe 64 kilobytes of memory for my program, and then you go into cloud and you have gigabytes. You go, wait a minute, and then they talk about so you have so much memory, memory almost becomes a secondary thought. So it's different things, different types of problems you have to work on. So more, it's performance, maybe much more important than how much memory you use. So you need to make sure something gets there fast. And cost isn't as important. Cost is very important in an embedded product because you got to buy a whole bunch of them and you want them small and cheap. So yeah, I don't know if you do the triangle of engineering with the cost versus performance versus.
Not yet at this point.
But yeah, so I mean that's one thing. This is something you always have to do a trade-off on, right? You have cost, you have performance, and you have time, right? How delivery time, right? So you have to get it there fast. So typically you have this triangle that's battling each other, and you can only optimize maybe two of the three. You can't optimize all three. So maybe you want to make it cheap and get it there fast, but it's going to cost you maybe on performance. If you want something that performs really well and meets a delivery, it may be more expensive, right? And then if you want something that's delivered on time and has good performance, maybe so you end up going towards two of those three, and the other one's going to be the one you have to make a decision on. So with each product, each customer, that decision and that which is the best solution is different. It's not always the same. Go ahead.
Is there something you wish you knew before you went into software engineering? Or for engineering, for that matter?
About the only thing I used to always say, I wish I probably would have gone into computer engineering instead of computer software just because of my inclination towards embedded. But in hindsight now, because of the things I'm working on now and the different things, it hasn't had a huge impact on my career or the path I take. It just meant this one part of it, maybe I had to learn more outside of school, whereas the other parts I understood from school. And the really cool part is a lot of the things I learned in school from day one on my job out of school, I was using. So that's not true in a lot of majors, but in software engineering, it's very true. In fact, they are hiring you for that skill, which is very exciting. And even when you're trying to, and then if you get a software engineering job and you're looking at work, there's different things you have to even trade off for, even on joining a company. Do you go to a big company where you can learn a lot maybe, but you may not have as, there's maybe different restrictions. You could go to a startup where maybe if it takes off, it could be, big, huge gain, and you can have a huge impact on the success of the company. So there's a lot of different things to trade off. And that's, you kind of base it on your personality, the things you like to do. You may want to just go in and start your own business because you have a really cool idea and you want to figure out and start programming and doing certain things. I had a high school colleague that went into, he really loved computer gaming, and he actually just went and started up he just started doing it on his own and ended up starting his own company and doing well with it. So, but it all depends on your personality and the things you like to do and how you want to trade off in life. So, I mean, some other cool things. What's that?
Let's see if any other questions out there. He's mentioned Bluetooth a few times. How do you think they came up with the name Bluetooth?
Yeah, why is it called Bluetooth?
Code name.
So it actually started from a Swedish company called Ericsson that is from a Scandinavian country. And the whole purpose of Bluetooth was to connect a whole bunch of devices together, very easily, so they're communicating and do things. In Scandinavia, there was Harold Bluetooth was a king that actually connected and united the Scandinavian countries. And so as a result, they named the Bluetooth technology after the king who united the Scandinavian countries. So, and even the Bluetooth symbol is like a Scandinavian rune. It's meant to look like a Scandinavian rune, letter B. So that's why it looks the shape it does.
See a few searches going on with finding King Bluetooth.
Harold Bluetooth. I used to have a picture of his tomb. I was in Denmark, and we saw that when I was working on Bluetooth, and we actually put it up on our internal web page for a while as our team logo, because it was good.
Any other questions there? All right, well then, thank you very much for sharing today.
You're welcome.
Go ahead, there's about 5 minutes left in class, so if you want to work on kind of pulling your thoughts together on questions there, do so on the worksheets. It's not due till tomorrow, but don't forget to do what? Hit the turn in button.
I knew that answer.
He's heard me a couple times say that.
Mr. Olive, this looks good for like the length of the answers and the amount of notes on the bottom.
Yeah.
Okay.
No, I'm.
I got a question.
Yes.
Are we supposed to be like